No, I know.
So the review, I'm going to start with chapters 1 and 2 today. Chapter 1, I'm not going to go through a bunch because we literally just did it. So there's not a lot to review. So you guys should be able to do.
Well, okay, but like for me, it's just because you gave us 6 formulas, and when I find it in my notes, it's still complicated.
You need to. I give you all those formulas. You need to know how to use them.
I know that's my thing.
Okay. So if it has a T on it, you're looking for a term, and S is for series. All right, sequence and series, and then there's infinite series that we did yesterday. Yes.
Should I just like go with you guys and just do this later?
Yes, absolutely. Okay.
What are you after that?
So there are going to be arithmetic.
Go with your own way there. Well, there's a video of that.
There we go. Are you uncomfortable now?
Okay, arithmetic series and sequences.
Questions for you?
I am already.
Oh.
Arithmetic, added,
Geometric sequences and series,
multiplying,
and then what we covered yesterday, infinite.
whatever you want.
So all 3 of those will be on there.
So is there even a page on every page?
What do you need?
Like, is there like a whole page?
On the test? There'll be more than a page probably for each part. Some will have more, some will have less. I can't remember it because I haven't looked at the test yet for a few years now, but. So, if you want some review questions for the test, I would go to page 66.
Fields of life that was once there.
Okay, there's your Unit 1 review.
That's so
Satisfying.
Okay?
Where is it? Review?
The machine is killed.
Yep. It's fine. Mine will start next week.
A big review at the end of the textbook.
What's that?
How many questions are in this big review at the end of the textbook? Or is it not like a
Is
big
it
long?
cumulative?
Well, I'm just giving, like, I go through each chapter review now, and I just give you questions out of that.
Oh, right.
Okay? So this is for chapter 1. Now, chapter 2. We're going to spend a little more time going over that today because this has been since September. So chapter 2.
Oh. This is not like trigonometry.
This is trigonometry. All right? So if you guys remember, right? We were drawing angles, remember?
Oh, this, that made no sense.
And then you draw your angle here off the x-axis. Right?
Yeah.
Oh, yum.
That's what I remember.
And these were quadrants, remember? One.
You know, after a while.
Oh, and then
basic
only like,
blood
you could
really
do like
stopped.
sine or whatever into that and stuff. That could be good.
Yeah. Oh, I remember those
So you have to
quadrants.
say what quadrant.
Yeah.
Awesome, dude. Good, bro.
Radical and
Yeah, then you can calculate certain angles and stuff like that. So there was like, then there was the angles, and then there was also the,
Look, bro.
you guys remember what this angle is called? It had an R here. No, that's physical science.
I think I read.
Oh, you're just reference angle.
Oh,
You know where
so
it's
okay,
at?
but like, let's say so if you find your angle or whatever, and then since it's 90 next corner, it's just subtract left.
Right, so like if this was, let's say, 120,
Arlington, Boston.
then you could find that this would be 60, right?
LSU is 60.
Now, there's also,
Florida.
okay guys, please. There's also these 60-30 triangles, remember?
Oh, it's specific.
You're given these triangles on the test too.
Yeah, well, we had to use this triangle for something.
There you go.
So are all the formulas going to be displayed like on like one piece of paper when it comes to starting Windows Winter? Will they split them before them like units?
I group them into units, but yeah, like I don't label what they are.
Yeah, that's good.
Okay?
Okay, wait, that's root of what?
Root 3.
Why would you repeat it?
Because these are just known values for these certain triangles.
Ah!
Okay? And then there was also the 45 triangle.
90 degrees.
So we can find known things of triangles based on these here.
I have a question.
Yes.
So, like in the provider but like when asked what like the root is, I like it's like just like a number that shows up on the paper.
You could, but I would leave them like this. I wouldn't punch anything in. Just leave them alone.
No, I know, but like I'm just asking.
Yeah, yeah. So for example, like let's say I want to know, let's go sine 60 degrees. Right, very good. Opposite over hypotenuse. My opposite would be root 3. Hypotenuse is 2. That's the value. Cosine 60. Adjacent over hypotenuse. And if you actually put cosine 60 into your calculator, guess what you get? 1/2. Right? These are the actual values. This is where they come from. And we talked about that.
Wait, why? Oh yeah, cause like that is like what it is in the calculator.
Yeah, these are the actual values. This is where those values in your calculator, this is where they came from. Yes.
I need to go.
Wait, isn't that adjacent hypotenuse?
Yeah.
So
Now, what's great is if you know an angle, let's say like 120, and I asked you to calculate, let's say, the cosine of 120, we don't know what that is based on these two triangles, right? But we can use its reference angle to find it. And because, so the reference angle is 60, we can use the 60 triangle here.
And I say it the wrong.
No, okay, but if you do that, then that means you only know what stuff with your reference.
Yeah, but it's the same, the reference angle equals the root or angle.
Interesting.
Like the values do, yes, they do. Yeah. Now, the only thing that changes is, as you go into different quadrants, certain things are different. In quadrant 1, all things are positive. In quadrant 2, only sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. So, if you were to actually punch in cosine 120, sine is positive, cosine 120 would be negative a half.
It is negative.
Right? Straight checks out. So you need to be aware of that.
So it's cosine 120 because it starts with whatever. But then, how is that?
Well, because.
It's just the value. Like, okay,
Does it always start on that line?
are you okay?
Yeah, it's fine now.
Yeah, go talk to you.
What?
He hit his mouth on practice. So let's just try one for practice here. Let's say I gave you an angle 225 degrees. Okay?
270. No. Yes. Subtract that.
Oh, not 270. It would actually work for this one with the number I gave. But you would go from here, 180.
Oh.
You take the measurement from here.
Oh.
Okay? You always take your measurement off of
Because
your.
it hasn't actually reached all the way around.
If it came around even, Levi, I'm going to draw this and I'll erase it because it's going to get messy. Like, let's say it came around to here, like this. You would take the measurement off of here.
So then you do 360.
Yeah. It's either going to be 180 or 360, okay?
Oh, it's never in between.
No, it's never 90 or 270.
Oh, okay.
Good question, though.
Okay,
So if I told you all this was 225, you would need to calculate what this reference angle is here.
Wait, so how do we know what our reference angle is?
It's always going to be off of the x-axis. So to find that here, Sierra, I know the total is 225. What's this angle from here to here?
So you just always, okay, so like, case like that line you draw, what's that line?
Which one?
The
This
line.
one here? This here?
The line that goes straight, yeah,
That's your terminal arm.
yeah, okay. So, okay, so whatever, like, you're, like, if you're 225, if you're 225, that's your term line, then you just measure to whatever x-axis is closest.
Yes. Okay.
And then that is your,
All right, so it's going to be 225 minus 180. My reference angle is 45 degrees.
okay.
So now, if I wanted to do
wait, what is it, sorry?
45, it's always going to be like 60, 30, or 45. That's all we know.
It's always going to be.
For these ones, yes, it works out quite nice.
Okay.
All right. So if I know sine is, let's say I want to calculate sine now, 225. All I do is I just look at my 45-degree triangle. Sine is
It'll be negative.
opposite over hypotenuse.
Want to be negative?
Because sine is.
Very good. Tangent is the only positive one. So you put a negative sign.
Okay, so it's sine 225.
Yeah.
So which quadrant's negative, which quadrant is the positive then?
Well, in quadrant 3 here, Jaden, tangent is the only one that's positive.
Oh!
Everything else is negative.
See.
Okay, wait, sine of 225. What?
Because you have your.
Yeah.
Okay, so then sine is opposite over.
Yeah.
But then,
Opposite over.
so is it 1 over?
Negative. 1 over. Yeah. Okay. Cosine would be the same, adjacent over hypotenuse. But tangent would be, let's go tan 225. Tangent is opposite over adjacent. 1 divided by 1 is just, and since it's quadrant 3, tangent positive. Okay? How are you feeling about that?
So, so A, all things are positive, S, sign's positive, or sign's negative, I mean.
Sine is positive.
Oh.
This is really positive.
I remember that for you.
Yeah, everyone should remember the acronym. I'm not going to say it because I'm
All
recording.
stickers take that.
I didn't say that.
I did.
Yeah.
Yeah.
Okay?
You could have just said all sloths.
All slots take carrots.
Slots come through.
All sloths.
All salesmen take cash.
Okay, so that's, oh, hey, salespeople. So that's 2.1 in a nutshell. Now, let's move on to 2.2.
All shops take.
It's not even true. Salesmen.
All shops take that. They're shopping.
So those are for only exact points. Now we're going to look at so we're talking about now any point on the graph with any coordinate, okay? Do you guys remember what this value here was for the terminal arm?
7.
No, we called it the radius.
Oh. Oh, because when there's multiples on there, it's like the radii or whatever.
That's what it looks like.
You'll get into like circles next year with it, or a unit circle, I should say,
Next year or next
Well, I only have
semester?
a-
next year.
Oh, okay.
Okay, so because this is a right triangle, we have an x coordinate and a y coordinate. R always equal r squared equals x squared. This is just Pythagoras.
Wait, why is that your radius?
Because that's just the term we gave it. We call it the radius.
Okay, wait, hold. Why do you have X and Y reference?
Well, okay, you have a point here on your grid that has x and y coordinates.
Because we had like case we we'd have like these really complicated word problems where you have like a building and we had to measure angles, figure out angles and everything. Is that this?
No. That's next. That's 2.3, 2.4. Okay, so this is on a grid. So if this point here is at x and y, you draw a straight line out to it. That's your radius. Then if you went straight down from it, that's your y value. That's the length there, your height.
Take your angle and your 90 degree, find your top.
Right.
And then now you can find your side.
Well, yeah, exactly. You can use Pythagoras to get your lengths.
This is like,
It is. This is like grade 9 trig, but we're using a grid now. And it also means we can calculate things like sine.
Yes.
Sine is opposite over hypotenuse, right?
wait, so our radius is always just going to be like our X and our Y added together.
Well, squared and added together. And then you take the square root.
Like this.
We'll do an example. So if I know sine, so here's my angle, sine is going to be opposite over hypotenuse. So that's just going to be y over r.
Would it just be y over r or y squared over r?
Y over r, yeah. Cosine is going to be x over r. Tangent, opposite over adjacent.
I remember that.
Oh, this is one thing that I missed. Okay, wait, so. Okay, so because it's your X, your Y, and then your R. So like from your angle, then that's just your opposite of the Oh,
Right.
that's all that is. It's like the angle.
Yeah, so like, for example, no, it really isn't. You guys did fairly well on this one, from what I remember.
Yeah, we're kind of good.
So let's say I have a point over here at -4 and 3.
So then you go to -4.
So my height would be 3, my length here would be 4.
Isn't that the
It would be, but because you're measuring,
if it's,
yeah, we leave it as 4. So if you want, you can put a negative there though.
wait, but if we put negative in our equation,
Well, remember this, we'll come back to that negative in a second. Yeah, the quadrant it's in, it's gonna affect a few things. What's positive in quadrant 2? Sine. Yeah, good. Y, you're right, Sam, yeah. Okay. So, let's calculate R first.
what's 9 plus?
You square them.
Oh,
Gonna finish it over here. R squared equals 25. R equals 5. So then my sine, cosine, and tangent are going to look like this. Sine is 3 over 5. Makes sense. Cosine, -4 over 5. Hey, look at that. Cosine should be negative. We're on the right track. And then tangent would be 3 over -4.
oh yes, and that's also.
Yeah.
This is actually makes sense. No math doesn't. This actually does.
This trick's us very straightforward, and you guys did really well with it. So, like, it'll really help you in pre-calc 30 if you take it. And then the last two sections, 2.3, 2.4, I'm not going to spend a lot of time on
Why?
because it was sine law and cosine law.
Oh, I know the cosine law. Like, it's,
Oh, isn't that weird equation?
I can't say it, but I can just write it. I can
Well,
write it down.
Sine C over A equals, the thing is sine C over C equals sine B over B equals sine A over B.
Yeah, I remember that.
Think cosine law.
This is 2.3.
Cosine law.
This is 2.3.
Hey, but then can we like one example?
2.4 was cosine law, where it's like
A squared equals squared minus B squared simple. A equals like
You got it wrong.
it's a mouthful.
Okay, wait, so like,
it's
is
not
that
sine
just
C on.
sine, oh,
Wait, why is there sine C? But it's just sine A and sine B.
You only use 2 of the 3.
Yeah, I was gonna say.
Yeah.
And when you find, you have to find the degree or the actual.
Yes. And you guys did this in Foundations 20, so it shouldn't be a huge.
Oh, I think
it's like, I'm
Is there gonna be like a cumulative, how do you say that, review?
Cumulative review.
Cumulative.
I'm giving you guys reviews chapter by chapter.
Awesome.
And if you want more questions, I can get way more questions. Okay?
okay, well. Oh, that's just an equation. I was like, 24 divided by
2.4. No.
Wait,
Do you guys actually need to see review questions on this? Would you like
well,
it?
no, but can you
Yeah.
do an example on each?
Sure.
And that's like,
all I need to see is on this paper, and so that I can just go and do some questions when I do my stuff. So I don't. don't know why, but everybody was always better. I was always better.
Here's mine.
Okay, and we're gonna solve for you guys want to do the angle?
Oh, I know what this is. Oh, it's bringing back my. Oh, you mean this is giving me mental break?
Oh, I see. Sucks.
What was the other one? 23.
That stuff.
Wait, is it?
Oh, don't you do like some cross?
Yeah, cross multiply. Mark that out.
Oh, this is when Miss Hesley played.
No, I thought I'm the only, this has
Hey,
a
no,
big.
no, no, I know, but like, somebody can, there was some teacher.
Sarah taught us this. She would have taught you this in last year.
Oh, yeah, because of that's for back every, oh, I remember her sitting at my desk and trying to do this.
I remember that. Chat right
He was a
there.
good teacher.
No, she was.
Yeah.
Then you divide both sides by 24.
Why?
Oh,
Because you gotta get sine by itself.
very
You
Yeah.
didn't have that in.
Not exactly, just like.
Yeah, you're solving for the angle.
You just cross multiply.
That was
So
fun.
you did 23.
Okay.
Thanks, Levi, for helping out.
Nothing's more fun than sledding around.
I did see.
Okay. So now I need to solve for the angle. You guys remember what to do there?
You just do your sign.
Very good. I don't even know why I had to do this. You guys are fine. Oh. 34.3 degrees. You guys want to do a cosine law one?
I actually never thought of it that way, like, just dividing the sign off. I always just like it. Sign.
What?
You what?
Well, you're like think about your like I don't know, just the way he did it, where like it says 34.3 equals the degree. I always just kept it at 34.3 degrees cosine.
Oh.
Yeah.
Now another way you could try doing this is you see here how I did cross multiplication on both sides.
Yeah.
See how I cross multiplied the 24 over, then divided by 24 anyways? You could just go like this, 23, cross multiply the one side so you get sine 36,
Divided by.
and then just leave it at 24. You can leave it like that. I recommend that. Save yourself.
It's just quicker.
Yeah, it saves you this step. Like this, doing this to this is redundant. But then you can just go from here to here to there. Right? Skip a step.
That's been what I never really do.
Yeah, work smart, not hard, right, guys?
Yeah.
That actually makes sense.
I don't know.
Because that's your direction to take numbers.
All right. So you guys want to do cosine law one?
You're smart.
Wait, but then how would I do that? Okay, like in this calculator, I do like sine 36.
Do it like this. Go 23. It's sine 36.
How do I get 13?
Okay, now go divided by 24.
Oh, and then you do.
Sine -1.
In my other calculator, I'd be able to just get my number, then click sine -1, but this it says sine.
You gotta hit second answer. to put it in. Like you see at the bottom there where there's that like negative sign? There's an answer thing there.
Oh, single.
Second answer is correct.
That's so
Yeah, I
dumb.
wrote like almost something.
Why, because it's easy?
Oh,
I used to like draw, like,
Okay, let's do a cosine law real quick, and then I'm gonna give you guys some time to work on stuff.
okay.
Well, I check in on Alexa. Okay, cosine law. Well, the numbers are too big. I don't got time. Okay, so for cosine law to work, you need an angle and the two adjacent sides to it.
Yeah.
Or you need all three sides to solve for an angle.
Yeah.
Okay?
So you, yeah.
Yeah, 52.
So because you already have two sides, you just.
Yeah. So I'm solving now for this opposite side to the angle.
Yeah.
So this is like my A value, so this would be A squared equal. Now it doesn't matter which one's A, B, or C. Yes,
Oh,
yes.
wait, and then we use this because we can't use sine.
Right, you can't use sine law. For sine law, you need the angle and its opposite side. Okay? Once you find this side, then you can go back and use, like if I have you on the test solve an entire triangle, you would use cosine law to get this side, then you could use sine law for your angles. You would need it for one, then you know the other one adds up to 180. Okay, so A squared equals,
So, do you like usually label your things?
not really. And now for these ones, I usually do them in 2 steps. Just to make sure I don't get anything wrong on my calculator. Like I would go 29 squared plus 28 squared.
What's the last number there? 0?
Cosine 52.
Out brackets or something.
And then I solve all of this. So I would go 2 times 29 times 28 cosine 2. I got it.
Minus.
Plus.
Yeah.
Oh, it's subtraction, sorry.
I knew I was right. You made me second guess myself.
So this would be 65. I think that's just 25, yeah. Isn't it?
Where's it? That's exactly. Like a 40-plus long test. It's like, hey, $40 to fix your results. I was so sick.
Question,
Really
are those-
hard.
Not paying for that.
Yeah.
Make it hard.
Find that too hard.
Questions about that?
Wait, 16, 45. Then what's that? That
For
A
like
with a line over it?
Where? Oh, I took the square root. You gotta take the square root at the end.
No, like this, you have 16, 25.
Minus 1,000.
Oh, so, okay, then to like find your other angles, then you do sine law.
Right, so now that I know that this is 25, I could use sine law for the rest.
Oh, okay. Just use it for one angle and do 180 minus 1.
Right, absolutely. Yes, good, Levi.
That's like,
Okay, for you guys to work on for this review on
You
page
get it hard saying right.
126.
Two dollars.
if you had $40, I'll do. One.
Oh yeah, okay, wait, so you're good people who got like 98 on who's got like the lowest one?
Usually, I think maybe 30 or 25.
Really?
Yeah, but they were one, so it's not too well.
I would do that.
It happens.
Wanting to not do well?
Yeah, like there's some people that just don't put any effort in.
Oh,
But then, do they even like pass the class?